We often view ancient Egypt as a civilization in a vacuum, an isolated empire defined by its geographical barriers and cultural purity. This perception stems largely from the accounts of the 3rd century priest Manetho. He wrote of a group called the Hyksos, describing them as a bloodthirsty horde from the east that conquered the land through sheer violence. Later pharaohs reinforced this narrative. Their inscriptions depict the Hyksos as savage foreigners who oppressed native Egyptians, a framing that justified their eventual expulsion. There is also a common historical assumption regarding the people who built the pyramids, that they share a near identical genetic profile with the population of modern-day Egypt. Much of what we believe about Egyptian history is based on accepting the official records of ancient victors as objective fact. Modern archaeology and a 2017 DNA study are now providing data that contradicts these long-held historical assumptions. By analyzing chemical signatures in teeth and bone, researchers are finding information that was never recorded in the ancient texts. This biological data is forcing a new perspective on how the world's most famous ancient civilization actually functioned. The investigation began in Avaris, the Nile Delta city identified by ancient sources as the seat of the Hyksos invasion. To find where these people came from, scientists used strontium isotope analysis. Drinking water leaves a permanent chemical signature in tooth enamel, mapping geographic origin. The Avaris burials showed no sudden arrival of foreign warriors. Instead, 77 early artifacts, like this tomb painting of the Amu people, show that these foreigners were traveling and trading with Egypt long before the era of conflict began. The later descriptions of a violent invasion appear to be a narrative invented by subsequent dynasties to delegitimize a population that had been integrated for centuries. While the archaeology at Avaris redefined the Hyksos, a 2017 study by the Max Planck Institute at Abu Sir al-Melek examined the broader Egyptian population. Researchers sequenced 90 mitochondrial genomes from mummies across a span of 1,300 years, from the New Kingdom into the Roman period. Given that Egypt was conquered by the Greeks and Romans during this time, researchers expected to see significant shifts in the local genetic makeup. The study revealed genetic continuity across the entire 1,300-year sample. Foreign conquests and centuries of rule by outside empires had almost no biological impact on the resident population. The genetic profile of the Egyptian people remained steady through centuries of foreign occupation and administrative change. This map reveals ancient Egyptians shared significant ancestry with Near Eastern populations, a connection less prominent in Egypt today. Modern Egyptians show an 8% increase in sub-Saharan African DNA, a genetic component absent in the ancient mummy samples. If the ancient genetic profile was so resilient during the age of the pharaohs, what caused the shift we see in the modern population? This shift occurred after the pharaonic era, driven by increased mobility along the Nile and the impact of the trans-Saharan slave trade over the last 2 millennia. The ancient genetic markers found in these mummies link back to the same Canaanite and Levantine regions that produced the immigrant Hyksos. These findings suggest that the modern Egyptian genome is a relatively recent development and does not directly mirror the population of the ancient past. This genetic data requires a reevaluation of the Hyksos and their place in the Egyptian story. Ancient Egypt functioned as a diverse, interconnected Mediterranean hub, sharing a genetic baseline with the Near East for over 1,000 years. Political narratives can be chiseled away or overwritten by the next ruler, but the biological data preserved in bone and DNA remains unchanged. Pharaohs could deface monuments and alter written accounts, but they could not erase the physical evidence buried in the graves of their subjects. The Egyptian story is a 4,000-year epic of migration, integration, and evolution.